in space when the signal
So coming to the
signals are
that is the testing stage.
so the
So coming to the Indian remote sensing satellite applications, as I said, NRSA is receiving the data from all these remote sensing satellites. So the first satellite was IRS-1A. So since then we have different kind of satellites. You have the remote Cartosat, that is for town planning applications. You use the Cartosat. Then you have OceanSat, that is for oceanographic applications. You can catch fishes also. I will tell you a small application for how to catch fishes. What happens is now in India, the temperature of Kashmir may be around 5 degrees, the temperature in Nagpur may be 30 degrees, temperature in Jodhpur may be 40 degrees, temperature in Kolkata may be 35 degrees, temperature in Bangalore may be again some 35 degrees. You are in India only, isn't it? But you have different temperatures. Okay. So similarly in the ocean also what happens? In the ocean also that the temperatures are different in the ocean. So wherever the hot and cold water mixes in the ocean, that is a comfort zone for the fishes. So those temperature variations we are sensing from the satellite at a height of 600 kilometers. We are having a very good sensor actually. That is called the thermal sensor. We have a thermal sensor which is called the sea surface temperature monitoring system. So we have high precision thermal sensor onboard satellite. With that particular satellite, we are going to sense the different temperature variations, the sea surface temperature variations in the oceans, whether it is the Bay of Bengal or Arabian Sea or the Indian Ocean. We will sensing that, and that particular data from the satellite we are transmitting to the ground station. So at the ground station, you are receiving that particular data, and what we will do, we will process that particular data. We process the data. We have the different kinds of levels of processing the data. We generate the product, and that particular product we upload to the network. We have the national network, so we upload to the network. And India is a peninsula, isn't it? We have a lot of coastal districts, coastal states. So each coastal state will have a nodal officer. That nodal officer, what he will do? He will take that particular data and he will communicate the data or translate the data which is understood by the fishermen. So this particular data, he will tell to the fisherman that this particular area or this particular latitude, longitude, you go and catch the fishes and you will get more fishes. So this is one type of application. And the second thing is fish food. So what the fishes eat, they eat the seaweed. Seaweed, scientific word is called the phytoplankton. Okay, so the sea algae. So wherever the fish food is there or the sea algae is there, the chlorophyll concentration is there, we have a sensor on board the satellite which will detect this particular chlorophyll concentration. So this chlorophyll will detect from the satellite sensors and will try to give the product to the nodal officer, this information to the nodal person, and they will again communicate to the fishermen. So this need to be done dynamically, isn't it? Because the fishes will not be at the place. So this has to happen within hours. So that is the most small application I am telling you. For example, we have taken a project in Maharashtra, Latur district. So Latur district state government of Maharashtra came to NRC. They wanted borewells to be done because they have tried so many borewells, there are no water at all coming. So they came to NRC. So we have given around 1,000 points. So we have given 1,000 points, 1,000 points. Around 990 points are successful. 990 successful. And again, why? Because how we do that? So with the help of satellite data, we will try to
launch an Earth-orbiting artificial satellite, Sputnik.
also. I need to.
Yes.
So what was telling? Borewell. So these borewells and all. So with the help of satellite data, what happens? We have different kind of sensors. We have an active sensor, we have a passive sensor. So this active sensor, what happens is it is having a penetration power, so it can go deep into the soil also. So this particular penetration, because of the penetration power, what happens is you can develop some models, 2D models, 3D models, and you can find out the groundwater table. So that particular groundwater table, we make it and try to establish where exactly the water is there. So like that, we have given some 900 points and it was very successful in Maharashtra only, because that it came to mind suddenly. So this is one point. And one more application I will tell you. For crop acreage, suppose you have a field which is thousands of acres, and you have put some cotton crop, for example, and you want to know where exactly some kind of insects are eating away and all. So you want to know health of the crop. So a physical person, each and every acre, he cannot go and see it, isn't it? So with the help of satellite, you can find out that also. What is the status of the crop, and you can also find out the acreage of crop, what is going to the yield, and that is one estimation. Simple things. A lot of applications are there. Suppose on the Himalayas during the winters and also ice is there. So how much ice is accumulated? and how much during summer the ice will become into water, and those water will be flowing into the dams. So how much of water is we are going to collect in the dams. So that kind of application. Lot of any field you take, all remote sensing satellite data, each and every place you are going to have it. And particularly the disaster management. Suppose there is a flood, or there is a volcano eruption, there is a forest fire, or you want to suppose you want to classify the forests. So many different types of forests are. Thick forests are there, thin forests are there, deciduous forests are there. Okay, you want to classify the forest. Suppose you want to see the estimation, like deforestation is going on. You want to estimate what amount of forest is available right now, isn't it? So that kind of estimation you can do. So a lot of things are there. It is a very big subject. Again, it will take a lot of time. So I am telling the few like applications so that you can explain to your student more what is the possibilities of exploration of utilization of the satellite data, how we can exploit the satellite data for knowing the resources, for finding the resources of the earth, and for the strategic applications also use for monitoring the border and military applications also we use the satellite data. So we have the satellite called Part-3, so that we are using for the military applications. So this is one set of satellite. Then the next category of satellites is a communication satellite. Hope you are able to.
Yes, sir.
Yes, sir.
Yes, sir.
So this is a communication satellite. So communication satellite, we have the GSAT series, that's a geostationary satellite series. These satellites are at a height of 36 kilometers. So this is the Earth. Assume that this is the Earth and this is a satellite. So the distance between satellite and Earth is 36 kilometers. At this particular point, what happens? The relative motion of the satellite and the Earth both are same. So 24 hours one revolution. This is also 24 hours one revolution. So what happens is both are same. Both are moving in the same speed. Because of that, we get the stationary effect. So we park the satellite at the particular point. That particular point is the geostationary point. So it is almost along the equator. So once we place there, so we are covering all our Indian region only. So with the help of this, we have the different kind of transponders on that. So whatever the internet broadband you are getting is the help of communication satellites, point-to-point communications. Then you have the live TV broadcasting also with the help of these communication satellites. Then the medical telemedicine also with the help of that. Each and every all the different transport we are giving lease to the different countries also. Adjacent countries are there. They don't have their own satellites. We give these particular transponders to these particular people to have the communication. So these are the set of the communication satellites. Okay, these are the heavy satellites. So these heavy satellites need to be launched from GSLV Mark 3 because the weight will be around 7,000 kgs. But whereas for the remote sensing satellite, the weight is limited. It is less than 2,000 kgs.